welcome to the video for Chapter 10. This is Lesson 1 about naming polygons and angle measures. The lesson essential question is, what are the angle calculations of a polygon? First, we'll start with some vocabulary. An equilateral means that all sides are congruent, which means that they have equal measure. Equiangular is when all angles are congruent, that means equal measure. A shape is considered regular when it is both equilateral and equiangular. Some examples: this shape is considered regular because it is equilateral and equiangular. This shape is just equilateral because, as you can see, only the sides are marked congruent. And this shape is considered equiangular because only the angle measures are marked congruent. A few more vocabulary terms. Convex is when a shape pushes out. All regular polygons are always convex. Concave is when a shape pushes in. This section, or this table, we're going to fill in the special names of some of the polygons when they have a certain number of sides. If it has 3, 4, 5, really it's 3 through 10. If they have 3 through 10 sides, then they all have a special name. Triangle, quadrilateral, and pentagon are for 3, 4, and 5 sides. Hexagon is what we call something with 6 sides. Heptagon is for 7, and octagon is 8. Nonagon has 9 sides. A decagon has 10 sides. And when something has any number of sides, it can have any number of sides, but they don't all have special names. There are some more that have special names, but if they don't have a special name, then it's called an n-gon. The n-gon would just be filled in with whatever sides it has, however many sides it has. So if it has 13 sides, it would be called a 13-gon, and so on. There are some, like a 12-sided figure actually is called a dodecagon, and there are some others that do have special names. These are for 3 through 10 sides, and the n-gon is if all else fails for anything above the 10. But you should be able to name 3 sides through 10 sides. These are examples. Please follow the instructions. Name each one based on the number of sides. Identify if it's regular or irregular, which, remember, has to do with the being equilateral and equiangular, and then determine if it is convex or concave. Please pause the video. Try to do it yourself before checking your answers. Here are the answers. Moving on to interior angles inside of these polygons. And we will actually be looking at exterior angles also, but we're going to start moving into angle relationships of polygons. So an interior angle sum formula: in any convex polygon with n sides, the sum of the measures of the interior angles is n-2 times 180. So we use this formula, S, which represents the sum. That's what the S word sum is there. So the sum of the interior angles is n-2. The n is the number of sides, just like from the chart when we were naming the polygons. N is the number of sides, subtract 2, and then multiply that answer by 180. Please understand there's no mention of regular polygons. It does not have to be a regular polygon. It just needs to be convex, which means it needs to push out. So any of these examples that we labeled as concave on the previous slide would not work for the interior angle sum formula. Further, the measure of one angle of a regular polygon, so now specifically drawing to a regular polygon, because if they are all regular, if it's regular, then it's equiangular, then the sum of the interior angles can just be divided by the number of sides, and then you'll figure out what one of the angle measures inside of a regular polygon is. So now let's take a look at some examples. So in this example, it says find the sum of the measures of the interior angles of a dodecagon. So the dodecagon has 12 sides. That's one of those polygons that does have a special name for 12 sides. You are not expected to memorize it, but a dodecagon has 12 sides. And figuring out the answer to this would just be using the formula. So if we take the 12, which is the n, 12 minus 2, it's going to be 10. 10 times 180 is 1,800 degrees on the inside of any dodecagon. Our second problem here is finding the measure of each interior angle in a regular icosagon, which is 20 sides. So we have 20 sides, subtract 2, multiply by 180. This is going to give us the total degrees inside the regular polygon here with 20 sides. So these are all of degrees, but we want one interior angle. So because it is regular, we can just divide by the 20 sides or 20 angles that there are to get 162 degrees. This final example is just going to need a little bit more space because we're going to be given the sum of the interior angles and we have to figure out how much or how many sides there are rather. So when we use this formula, we know S. The sum is 5,040. So we solve this by first dividing by 180 and then adding 2. So we divide by 180 first. We don't distribute. You can, it just takes a little bit longer and deals with larger numbers. I'm just going to get rid of this multiplication right off the bat by dividing both sides by 180. So there are options, but this is just the fastest way to do it most efficiently. And then just add 2 to both sides. So the 30gon has 5,040 degrees on the inside. All right, so that was a lot of chatter about interior angles. What about the exterior ones? Well, any convex polygon, the sum of the measures of exterior angles is 360. Yep, no matter what. It doesn't matter how many sides there are. It doesn't matter if it's regular or irregular. A convex polygon will always have the exterior angles adding to equal 360 degrees. So we can use that information to find missing exterior angle measures. One thing to notice about the exterior angles is that they kind of turn into like propellers. If we look at this triangular one, it's not extending in both directions. Like this would be an issue. We shouldn't have the line extending in both directions. We only want it extending in two directions, or sorry, in one direction. So it's going this way, this way, this way. We shouldn't have anything more than a line at each vertex. So over here, this is a vertex of this quadrilateral. There's the line, one extension, one extension. You shouldn't end up with like a starburst kind of figure, more propellers. So this first example here, I'm just going to go ahead and add the 2 exterior angles that I know, subtract them from 360. So X, this missing exterior angle, is going to be 139 degrees. And then this one over here, I'm going to go ahead and add the 3 angle measures that I know, 77, 122, and 117. I get 316. So the 316 degrees plus this 2x, so the 2x plus the other 3 angles is going to equal 360. Subtract 316, divide by 2, x is going to represent 22. I'm not putting a degree symbol on here because there's nothing that's actually 22 degrees. X represents 22, this angle measure here is actually 44. I did put a degree symbol over here because x represents a degree. Taking a look at some word problems, find the measure of one exterior angle of a regular nonagon. Well, it's regular, which means it's going to be split evenly. It's a nonagon, which means it has even sides, 9 sides. So if the 9 sides are splitting it regularly, exterior angle is they're all going to be the same, and exterior angle is 360. So I'm going to take the 360 and divide that by 9, so it's going to be 40 degrees. Okay. The one exterior angle of a regular polygon is given to be 24 degrees. Then what times 24 is going to give us 360? Again, it's regular, so it's going to be split evenly. So each one is 24. Well, how many are there? Like what times 24 is going to give me 360? And so we just divide and it ends up being 15. So 15 does not have a regular name, at least not one that I can think of. And so we're just going to call it a 15gon. Final challenge question here. We have 1, 2, 3, 4, 5 sides. So this is a pentagon. It is not regular, and the x shows up twice as an exterior measure. The y is interior. We could find some interior angle measures. We could use a linear pair here. We could use a linear pair here. We can't here because I don't know what this is. This is a 2x here. I don't know what that is. But we probably could do some manipulation to figure out what the interior. But looking at the exterior angles, I actually know or have something for all of them because this down here is 90. The linear pair is going to tell me that this exterior angle is also 90. So I have an X, a 90, a 60, a 2X, and an 81 that will all add to equal 360. So in purple over here, I've added that together and solved for X being 43. So once I know that X is 43, I can subtract from 180 to get 137. So this green work over here, I'm using a linear pair to figure out what Y is now that we have found X. So again, in purple, all 5 exterior angles add to equal 360 degrees, just solving for X that way. That concludes this video lesson on naming polygons and angle measures. So what are the calculations for angles of a polygon? For interior angles, it's n-2 times 180, and for exterior, they're all 360 degrees. Thanks for watching.